Module 10, Lesson 3 covers theoretical probability in simple events. Textbook claims this will be a 2-day lesson with 14 resources. It's possible. Let's see where they take us today. At carnivals and fairs, you can play games to earn tickets or credits to trade in for prizes. Some require skill, while others are a game of chance, which means they require luck. The spinner shown has 18 equal sections. Suppose the spinner is spun once. Landing on a number less than 5 means you win a prize. What are some ways you can determine how likely it is that you will win a prize before you play? These are some of the questions we're going to be learning how to answer in today's lesson. The inquiry question asks, how can you predict relative frequency without performing an experiment? And we're going to use a web sketch in order to figure this out. So, suppose a spinner shown is spun 10 times. Predict how many times the spinner will land on red. Record your prediction and then press 10 spins to record the relative frequency of the spinner landing on red. Well, looking at that spinner, half of it's red, half of it's not red. So, out of 10 spins, how many times do you think it's going to land on red? Well, I'm thinking 5 because that would be half. So let's go ahead and hit our 10 spins, and it's spinning, and look at that. 5 times it landed on red, 5 times it landed on blue. Will it happen that way every time? I don't know. Let's try again. So now we did 10 and 10, and now we're going to do 15 and 15. Now we're going to do, oh, it got off balance that time. On that one, it did not end up being the same exact each way. But the theoretical probability, that's a term I was looking for in the last lesson, the theoretical probability is that it's going to get 5 out of 10, or 50% of the time, on red. How do you think the results would change if you spun it 100 times instead of 10? Well, theoretically, it would still end up being half. But let's find out how it works. They did their spinner, and they're counting up all the spins, and wow, this is going to take a minute, so y'all just pause. And there we have it. You can see that time it was 52 out of 48 times that it actually, 52 out of 100 times it actually landed on red, with 48 of them landing on blue. Would that happen every time? Absolutely not, because theoretical probability and experimental probability are two different things. Theoretical probability says what it is most likely to be, while the experimental probability, that changes every time you spin the wheel. I think we've spent enough time spinning those wheels, so let's move on to learning about sample spaces and simple events. In a probability experiment, the set of all the possible outcomes is known as the sample space, another new vocab word. To find the sample space of a simple event, you can make a list of each unique outcome. When rolling a number cube once, the sample space of the outcomes of each face are going to be 1, 2, 3, 4, 5, and 6. Those are all the possibilities that you could get on that number cube. Now suppose you rolled a number cube 10 times and recorded the results as shown. The relative frequency shows rolling a 1 or rolling a 6 are both going to be 0, or 0 out of 6. Because rolling either of those numbers did not happen. Now, I don't think they're actually right here. Rolling a 1, I agree, happened 0 times, but they claim that rolling a 6 here happened 3 times, so their chart doesn't match up with their words here. The sample space 1, 2, 3, 4, 5, and 6, even though 1 or 6 did not happen, 6 happened, it's there. All the possible outcomes are included in the sample space. The sample space did not depend upon actual results. So what does that really mean? Even though 1 didn't occur, you still had to put in your sample space as a possible outcome. For example 1, they've taken the word mathematics and they wrote it down, they cut it up into individual letters and placed them all in the bag. And now they say you're going to draw one letter at random. What is the sample space? The sample space is going to be each of the letters involved in it. So Let's take a look here. You can see that drag the tiles that represent the sample space. You have, I think it's probably going to be all of them, M, A, T, H, E. We're going to leave that M alone because we already have an M. We're going to leave that A alone. We already have an A. We already have a T. We don't have an I. We don't have a C. And we don't have an S. So checking it, we got the answer right. You don't repeat the letters in the sample space. You can only use them once, because once you have a 5 or an M, you have an M. You can't have more than one. M can occur more than once when you're actually drawing them, but the concept of M itself can only occur once in your sample space. Now it's going to be your turn. Find the sample space of the spinner once it find the sample space. The spinner is shown is spun once. What are the possible outcomes? What's going to be in our sample space? Now looking at this, I see reds, greens, blues, and yellows. So that is what it's going to be. B. Yes, I know there's 2 blues. Even though it occurs twice, we only list it once. So answer B is going to be our correct option here. Experiments such as rolling a number cube or tossing a coin, in which all the outcomes are equally likely to occur, are known as uniform probability models. In the old textbook, we refer to them as fair. It was considered a fair event if all the events had the same likelihood of happening. Let's go ahead and highlight that vocabulary term, and then we can say theoretical probability based on uniform probability, or what should happen is going to be the probability of that experiment. So looking at some flashcards here, the theoretical probability is a ratio of the number of favorable outcomes to the total number of outcomes. Same formula we've been using, and we would use a formula: probability of the event is equal to the number of favorable outcomes divided by the total number of outcomes. Same formula we've been using, only now they're adding the P event into it. Scrolling down, it says the probability number line shows the sample probabilities that correspond with likelihood. Select each button to see the probabilities expressed in different forms. So, as a fraction, impossible means it's not going to happen. A 1 out of 4 chance, not very likely. A 1/2 chance, equally likely. 3/4 odds, likely. And 1, it's a guaranteed sure thing. Looking at that as decimals, you have 0, 25 hundredths, 5 tenths, 75 hundredths, and 1. And as a percent, it's going to be 0, 25%, 50%, 75%, and 100% guaranteed, can't miss. Moving on, suppose you toss a coin 20 times and record the results are shown. The relative frequency of the coin landing on heads was 17 out of 20. That means the relative frequency of the tossing a tails was 3 out of 20, because each outcome when tossing a coin is going to be equally likely to happen as to not happen. Now, all that said, the theoretical possibility was 1/2 for 50%. Heads just got luckier more, and the theoretical probability therefore of tossing the tails, that was also going to be 50%. The tails, it just got unlucky. What are the relative frequency ratios? Why are they so different from the theoretical? Because the theoretical probability is what you should expect when conducting an experiment, while the relative frequency, also known as experimental outcomes, that's what actually happens. I think we're going to end this video a little bit short. The module's too long for one, but not long enough for two, really. So we're going to do 2 short videos here. Come back and watch part 2 in just a little while.